Hey y'all. All right, this is the continuation of 3.7 from class, implicit differentiation, as opposed to explicit differentiation, which is what we've been doing all along, where you have already solved for y in terms of x. This is where x's and y's are all mixed together. I'm just going to get right to the problems here. This is the third time I've tried recording this, so I'm not very good at this yet, but I'm working on it. Okay, first problem. X cubed plus y cubed equals 6xy, shown to the right. So clearly that is not a function. So we're told to find dy dx. All right, so I have to rewrite the equation. By the way, what we're doing here is something we've already done in class. We solved, or we did the derivative, and we went ahead and did the algebra and solved for dy dx by isolating it and moving everything else to the other side. That's all we're doing here. There's nothing that you have not seen today. So there's nothing new, but I'm going to go ahead and do them, just for fun, because calculus is fun. All right, so let's see. What do we get when we take the derivative here? We get 3x squared plus 2y. Why did I say 2y? 3y squared dy dx, because we need a chain rule, take the derivative of y with respect to x, equals 6. Let's see, the first one times the derivative of the second one plus the second one times the derivative of the first one. And clean all this up a little bit, and we get 3x squared. It's not really very clean. Okay, and then we need to move all of the dy dx's to one side. I'm going to choose to move them to the left side. And all of the other terms to the other side. And then we factor out the dy dx. And then we divide through by the other terms. I'm going to divide through by 3y squared minus 6x. And then if I went ahead and pulled a 3 out of everything, I would end up, and then canceled top and bottom 3's, I would end up with 2y minus x squared over y squared minus 2x. Okay, I need to save that for the next part of the problem, so I'm going to try to copy it. See if I can do that. There we go. Copy. Next page, paste. There we go. All right, part B says find the equation of the tangent line and the normal line to the graph at this point. The point is a little messy, 4/3 and 8/3, but it kind of works out in the problem, so don't be too intimidated by it. Okay, so this was my dy dx, my slope, or my derivative, or my rate of change as y changes with respect to x. How do you find the actual slope at this point? Well, you just plug it in. So I get dy dx equals, let's see, 2 times y minus x squared all over y squared minus 2x. Okay, I'm going to pause the video for just a minute and do all the math here, just the arithmetic, and I want you to do the same, and then you pick up when you're ready to go. Okay. All right, I'm back. Magically, there's all the arithmetic, and the answer at the very end is dy dx equals 4/5. So my slope of this function anywhere at any x and y, think about it, is equal to all this, well, no, that's true. The slope at any point along this graph here is equal to 2y minus a squared over y squared minus 2x. And when I actually plugged points in, I found out that the slope at 4/3 and 8/3, so 4/3, somewhere around here, and 8/3, so it would be somewhere up here, is equal to 4/5. So the rate of change at that point is 4/5. Okay, let's look at the next problem. Oh, wait, we haven't done the equation. Okay, so the equation of the tangent line they've already given us points, and we get y minus 8/3 equals 4/5, that's the slope, times x minus 4/3. And the equation of the normal line, or the perpendicular line, would simply be y minus 8/3 equals negative 5/4 over x minus 4/3. All right, let me just check my work against my worksheet here, make sure I haven't made any typos that I can see. I think I'm okay. All right, so let's look at the next problem. Find dx dy at 0, 0 of the function tangent x plus y equals x. Okay, anytime you have some kind of trig function of something in parentheses, I hope you realize, maybe by now, that this is going to be a chain rule problem. Okay, so what we need to do first is find the derivative. So I have to rewrite the problem with parentheses. Now, to find the derivative of this, you simply just start taking the derivative. I like implicit differentiation because I like not doing the algebra first. I like just going ahead and taking the derivative because I understand that. I know how to do it. I know the rules. It's not hard for me. And then I can do the algebra afterwards. To me, it's much better this way than attempting to solve for y first, because how would you possibly solve for y when this is the equation you have? Oh, it would be so messy and ugly. There would be many trig identities that you would need to use. All right, so let's just go ahead and do this. So the derivative of the outside is secant squared, leave the inside alone, times the derivative of the inside, which is going to be 1, because the derivative of x is just 1. You could think of it as 1 dx dx if you wanted to, plus the derivative of y is dy dx equals the derivative of x is just 1. Okay, so what do I need to do? I need to get dy dx by itself. All right. I'm going to just divide through by secant squared of x plus y. And on one side, I'm going to have 1 plus dy dx equals 1 over secant squared x plus y. Now, when the secant is in the denominator, what is that equal to? That is the same thing as the cosine of that same angle. So 1 over the secant squared x plus y is the same thing as the cosine squared x plus y. So I'm going to change that out. Now I'm still trying to get dy dx all by itself. So I need to move this 1 over. I just need to subtract 1 from both sides, and I get dy dx equals cosine squared x plus y minus 1. And was I told, oh yes, I do need to find, oh no, wait. Well, that's the formula for at any point. At any point along this function, this is the slope. So now let's find the actual slope at 0, 0. What will that give us? That will give us the cosine squared of 0 plus 0 minus 1, which is the same thing as the cosine squared of 0. Oops. Minus 1. I think I said plus just now, but I wrote it right. All right, so what is the cosine of 0? The cosine of 0 is, I'm waiting on you to say it. Okay, I'm going to assume you did it right. It's 1. So we get 1 squared minus 1. Final answer, dy dx equals 0. The slope of the tangent x plus y equals x at 0, 0 is 0. And I think that will do it. Yes, that, no wait, there's one more page here. What's the last page? Oh, it's blank. Psych. All right, so that does it for the notes, and I think you can do all of 3.7 homework. I don't think this will be too hard. You guys let me know if you have any questions, and I will talk to you Friday. Okay, bye.